Hello everyone, welcome back to the Java tutorial series. In this video, we will begin learning about the Java collections framework. Okay, this is one of the most important topic, and this is the favorite area for the interviewers. So by the end of this video, you will understand what a collection is, why collections are needed, and what is Java collections framework, and we will see collection hierarchy, what are the different interfaces which are involved in collection, list, set, queue, and map. So when to use which collections, all those things we will cover as part of this video, and we will go in the layers. Okay, so let's get started. So what is a collection? What is a collection? So collection is an object that stores multiple objects together. Okay, so instead of creating many separate variables, we can keep related objects inside a single collection. Okay, so this makes storing, retrieving, updating, and deleting data much easier. Okay, I will give example of each and every one so you will be more clear. Okay, so a collection is an object. What is collection? Collection is an object. How do we create an object? Using new keyword and the class name. So that's how we create the object, right? So a collection is an object that stores multiple objects together. Okay, so how these things happen in the memory area, I will explain you. Okay, and instead of creating many individual variables, we can store all related objects in a single collection. Okay, so I will show you once how it works. So let's say we have, as we all know, right, we have memory areas, stack, and heap memory. So whenever we memorize in terms of memory, the concepts are much clearer. Okay, method area, we know, right? In method area, dot classes file are loaded. So let's say, since we have not covered collections yet, but I am showing you an example so that you will have the how it is happening in the background. Okay, so I'm taking list in this example. So let's say, okay, so I will start with method area. What is the functioning of method area? Whatever classes file, dot class file are involved in the application, that will be loaded in the method area. Okay, so let's say I'm using let's say list. Okay, this is one of the collection. We will learn what it is and how it is, but just for memory how it works, we are just revisiting. Okay, so let's say list.class is loaded in the method area, and let's say we have another class called created as student. Okay, we know, right, how to create class. In IntelliJ we have seen we have created so many classes. So student is one of those classes, and list is what? Collection. We are going to read it. This is collection. So as we know, array we know, right? In array, how it works in array? In array we have the collection of numbers. In array we used to have, right, 1 2 3 4 5 6. So in array, I'm showing you array in the heap memory. Okay, for now. So in array what we have? 10 20 30 40 50 60. Okay, like this we have in array now. Okay, and this is like, let's say array.class, arrays.class. Okay, so it is referring to array.class, and we have class pointer. Okay, class pointer will refer to the array.class. Okay, and in array, let's say his array name is let's say arr. Okay, this is the name of the array, and what it contains? It contains the integer values. integer values 10, 20, 30, 40, 50, 60. These are what? Integer values. And name of the array is ARR. So ARR is holding the memory location of this array, and that's why it is referring to this one. So ARR is the reference variable. So this is what we have learned so far. So we have array, and in this we are putting a integer values. Okay, so this is array, but now we are this is list. Okay, list. This is collection, like array only, but there are many differences. We will see one by one. But as part of the memory, how it is functioning, we are looking. So there also one class pointer will be there, right, in list. And let's say I am in stack, I have defined list. It is holding memory location of this list in the memory, so it is referring to this one. Okay, now class pointer will point to list.class, correct? And now in array, what the array is holding? Array is holding the integer values, right? These are values 10, 20, 30, integer values. Okay, but in case of collections, in this case we are taking example of list. List is one type of collection. So here we will not be having values. Okay, here what we will be having? Another object. Okay, another object. So let's say I have another object called student. This is what? Student. And you can think like there is another reference variable. Okay, another reference variable. You can think reference variable here. Okay, student 1, let's say, and it is referring to this one. And student has, let's say, name, and student is having name and age, let's say, these two properties. And class pointer will be there. Class pointer will point to student class. So what is the difference between the array and the list? See, in array we are having values 10, 20, integer values, right? And whereas in list, instead of having values, we are having object. This is what? Object. So in each field we will be having object. Instead of values, we will be having object. Okay, but what kind of object will be having? So we have created one class called student, and we have created a student object. How do we create a student object? Using new student, right? So this object is referenced from here. Here we will be storing a reference variable. You can say student 1 is the reference variable, and it is referring to this object. Okay, like here list is a reference variable, so this reference variable is holding the memory location of this list, so it is referring to this. Since here array ARR variable is holding the memory location of this array in the heap memory, that's why it is referring to this array. Okay, so likewise inside list collection, instead of holding values, it is holding object, but object will not be there inside the list. Instead, it will hold the memory location of this object. So it will hold the memory location, and from memory location it will refer to that particular memory location. So in that particular memory location we will be having a student object. Okay, so like this we will be having another student object, let's say student 2, and here it has student 2 also has name and age. Okay, so this student 2 is objects also sitting in somewhere in the heap memory, so that location will be stored here, student 2. So memory location of this object is stored in the list, so it will refer to this object. Okay. I want to show you only difference is that in array we used to store values, and whereas in collection we are, instead of values, we are storing the object reference. Actual object will be sitting somewhere in the heap memory, some other location. That location will be mentioned in the collection, so that this will be referring to that particular object. Likewise, we will be having a number of objects, student 3, so this will be referred here. This will be having student 4, so this will refer here. So each and every block list will have their own object. Okay, I will show you once more. So what we have, stack memory. Okay, what is another memory? Heap memory. And the last one we have is the method area. Okay, now let's say I will show you code wise. Okay, let's say we have list of student list equals to new. Okay, new, let's say list. Okay, I will go with the syntax, and list dot add new student, and we can provide name and age. Okay, name and age. Then again list dot add new student, again name and age. So I will explain you line by line, don't worry about what I'm writing. So just to show you the memory flow, I'm giving you first a glance of the collection. So that's how we define the collection, right? List student, list of student, this is generics we will study. Okay, for now you focus on what I'm showing. Okay, so here we created one object of list, new list. So we already know whenever we use new keyword, an object is created in the heap memory. But before going into heap memory, we will go into method area. Okay, so first, what and all classes are involved in these 3 lines? First class is list, so we will write list dot class. What is the next class? Student, so student dot class. And remember, list is built-in class given by Java, and student class we have created by our own self, that is user defined. Okay, so in the previous examples we have seen how to create classes. Okay, we can create our own class name, and we can give properties and behaviors. We have seen, right? So like that we have created one student class. So this is list of students, in which we will be having list of students. So this is what reference variable, right? And it is referring to object new list. So we are going memory functioning for first statement. So list is what? Stack. Reference variable will go into the stack memory, and since we are using new keyword, so object will be created in the heap memory, new list. So we will create here one list in the heap memory. Okay, so first there will be class pointer, which will be pointing to, okay, I will start from here. Class pointer will be there. Okay, so class pointer will point to that particular class, list dot class. New list is there, right? So this is which type of class? List. Okay, so we have created object new list in the heap memory, and the reference variable is sitting in the stack memory. Okay, and stack memory, this reference variable will hold the memory location of this list. Okay, so since object is created in the heap memory, so it must be sitting in some location of the heap memory, right? So that particular location will be assigned to the stack variable. So it will refer to this particular object. So first line is clear, right? And in list we will be having multiple objects. Since this is collection, it will not hold values, it will hold objects. So each of the field will have the object. You can say object or object reference. Object reference. Why we are saying object reference? Why we are not saying object only? Because actual object will not be sitting inside the list. Actual object will be created somewhere in the heap memory. Let's say student 1, okay, and let's say student 2, student 3, student 4. Okay, I will take only 4 students for this example. So these 4 student objects is sitting somewhere in the heap memory. Okay. If you see second and third statements, okay, so new student, forget about this list.add, okay, focus on new student. So in second and third statement, we are creating an object of student class. So student object of a student class will be created in somewhere in the heap memory. I have written here only 2 times, but I have created 4. You can write 2 more, okay. So student object created and sitting somewhere in the heap memory. So it might, all 4 students might have some location, memory location, okay. So those memory location, so when we say list.add means this is object, right, new student. So we have created a student object and we are adding to the list. So when we say .add, that means in whatever location this object is sitting, the reference variable, this location will be stored here. Let's say some location x06, x07, whatever. Okay, just to make you understand, I'm taking example. So let's say x06, some memory location. So that will be stored here, x06. So memory location is stored, so it will refer to this memory location. So that's why I told, instead of object, I told object reference. Object is sitting somewhere in the heap memory and we have the memory location of that object. That's why it can refer to that particular object. So that's why I told in list we have the object reference. Okay. So, or you can say in other words, like list will not contain values as we just saw the example in array. There we were having only values 10, 20 integer values. But here instead of values, we are having objects. Likewise, we have created student2 object. So this location will be stored here and this will refer to student2. Likewise for student3 and for student4. Okay, I will create one more student5 and student6. So this is the main list. Okay, this is the main list. Okay, this is the main list. So list is one of the collection. Forget about what is list and all. I will tell you in detail what it is. But for now, the memory area, how it is functioning, just try to understand. Here you can see different type of collection. So basic understanding should be a collection will have objects. See, objects are sitting somewhere in the memory and object reference is located in the collection. For this example, we have taken example of list. So this is the basic difference between the array and the collection, because array we will be having values, but here we have object reference, which is referring to object in the heap memory. So this is list of student. Okay, that list of student means list is the collection And this list collection, we have the student objects, student objects, student objects. And while creating student object, we have passed name and age. Okay, here we'll pass something Vicky 23. Okay, Rahul 24. So whatever values we'll assign to this, these values will be here, name and age. Here name and age. Okay, Rahul 24. Whatever, Vicky 23. So for all students, name and age value will be residing in the student object. Okay, and each student object will have class pointer as we have in the list class pointer, right? So each student class will have their class pointer. CP I am writing, okay, short form. So those class pointer will point to student class. Class pointer will point to student class. As you can see, class pointer of list is pointing to list.class. Similarly, okay, and this class pointer will also point to student.class. So when I am doing list.add, that means the memory location of this is object, student object, this object we are using new, right? New means object creation. So this object memory location will be stored in the list. So it will refer to this particular object. So this is the memory representation for how collection works. I hope you got some clarity. Okay, I have given you just first glance of the collection, how it works. Okay, we will go again to the definition now. Now you will understand better. So what is collection? Collection is an object. Just now we see an example, list. Okay, list was the collection in our example, that stores multiple objects together. So in example, we have seen multiple objects, multiple student object. We have seen an example, right? So a collection is an object which stores multiple objects together. I hope now it is clear. Instead of creating many individual variables, okay, we can store all related objects in a single collection. All related objects will be present in the single collection. Okay, before collection, how we used to store every student object, we were storing in some another reference variable. Student 1 equal to new student, student 2 equal to new student. So for each student, we were holding into the individual variables before collection. But since we are having collection, so collection will store all related objects, all student objects in our example. Okay, so this is collection. Collection will store multiple objects together. Okay, so this is just a collection overview. Okay, now why do we need collections? Why we are reading this concept? Why it is important? So it is saying without collection, so we are imagining, okay, we are not having collection. Without collection, how we will work with the variables? Okay, so we need to define 100 of variables. So in the last example, student object, there are multiple student object and those are assigned to the list collection. So if we don't have collection, means for each student object, like say new student, let's say Vicky, comma age 20. Okay, I will assign it to some another variable, student X, then again student Y equal to new student, whatever, Rahul 24. Then again I will define student Z equal to new student, whatever it is, Rahul, okay, Vicky, Rahul, Priya 25. So I am holding this new student object, all student object into the respective new reference variable. Every time I am creating new variable, see, So if it is 100 times, 1000 times, then I need to create 100 variables, right? For storing those objects, referring those objects. So here it is written 100 of variables we need to create. An array also store multiple values, right? In array also we have seen, in array we will store what? 10, 20, 30, 40. Here we don't have objects. Here we have values. These are what? Integer values. So store multiple values. Array will store multiple values, not objects. But the problem with array is it is fixed in size. We cannot increase or decrease. Whenever we create an array, we provide size. That size will be created in the heap memory and we cannot change it further. And we can perform some limited operation. This is the drawback of array. But in order to provide solution for all of these problems, collections come into picture. Okay, how collections will provide dynamic in size as we fill the objects. Okay, as we put the values, size will increase automatically. This is array. I am telling you about collection. So let's say this is list. We added one student. Okay, we have seen just now list dot add and one student object, new student. So one student came here. Then again we added. Okay. Then again we added. Okay. So as and when we are adding, size will grow automatically. That's why dynamic in size. And suppose after adding, we want to iterate. We want to go through each of the object. Okay, we want to go through each of the object and let's say I want to print all the name of the student. So traversal, easy insertion and deletion, that is also easy. Deletion, if we want to delete this student, I can delete it. Suppose I want to insert some student in between here, one more, that is also easy. I want to search any student object by name, by age. I want to sort student by age. Sorting means decreasing order, increasing order. We want to sort it, okay, based on the age. So those operations we will see. Don't worry about those things. But I want to say the operations can be performed in the collections very easily with the built-in methods. And also we can give our own logic as well. Rich API, okay. So these are the advantages of the using collections. So I hope you understood the problem defining 100 of variables and in array limited size, limited operation, fixed size. So these were the problems which were overcome by the collection. How dynamic in size, insertion, deletion, searching, sorting, these operations are very easy using collections framework. So that's why we need collections. Okay. So I will give you one more example. Imagine storing the names of 500 employees. Now, creating 500 variables is not practical, right? So array will solve this problem to some extent. How? Arrays have fixed size. It will create 500 employees and it will give the limited functionality. Array can also store objects, but the problem is limited functionality. Collections overcome these limitations by offering dynamic resizing. How? Because many built-in methods for managing these operations and data efficiently. Okay, collections. Okay, we'll move on. I think Java collection framework. Okay, so Java collection framework is a set of interfaces, classes, and algorithms, okay, provided by Java. So this is framework. Framework means there is some implementation which is provided by the Java. Okay. So a framework that provides interface, classes, algorithms. Okay. Interface we know, right? Interface means only method declaration will be there. Method declaration. I hope you know method declaration. Method declaration means what? Only what part will be there, what that method will do, but method definition will not be there. I have given you one example also, int add, okay, int a comma int b. That's it. Logic is not there. What it will do? Only what? Add two numbers. That's it. This is method declaration which will be present in the interface. Classes we already know. Class will have what? Properties and behaviors. Algorithm is provided by the framework. So there are various examples, array list, linked list, asset. Okay, we will see each of these in very detail. These are the examples. So I hope by now you are clear, like what is the use of collection, why we are using the collection, how the problems are getting solved with the collections. Okay. So collections are dynamic in size and many built-in methods are there. Okay. So I will give you a basic collection hierarchy. Okay. So let's say collection is the interface. Okay. Collection is what? Interface. Now collection is a parent interface. We have already studied like interface also follows the inheritance concept. Inheritance means what? Parent and child interface. So collection is a parent interface and child interfaces are list, set and queue. I am telling you the collection hierarchy. Okay, very basic. So collection is a parent interface. This is what? Parent interface. Parent. And these are what? Child interfaces. List, set and queue. These are what? Child interfaces. We are not saying child classes. In this case we are saying interface. Focus on the word. Okay, child interface. So collection. So whatever the methods defined in the parent interface will automatically accessible with the list interface, set interface, queue interface. Okay. And I hope you are aware of the interface and the implementation class concept. Okay. So let's say we have any interface, list, set and queue. So the class, any class will be there random. Let's say XYZ implements. So for interface we used implements. Okay, implements. Interface name is, let's say, list. Okay, so this XYZ class is implementing list interface. Okay, so what do we call this class? Implementation class. Why we are saying implementation class? Because this class is implementing some interface, that is list in this case. So the class which implements the interface, we call it as implementation class. Focus on the terminology. Okay, I will use this multiple times. That's why I'm explaining. So collection is parent interface and list, set and queue are the child interfaces. And the class which will implement these interfaces, list, set or queue or any interface, that class we call it as implementation class. As simple as that. And this is collection hierarchy. And apart from collection hierarchy, there is another hierarchy. Okay, so map will have separate interfaces. It is not linked with the collection interfaces. Okay, so collection have different interface hierarchy. See, collection interface, this is sub interface. Sub interface we can call or child interface, whatever it is. So remember, collection is the parent interface, list, set and queue are the child interface or sub interface of the collection. Okay, and map is a separate hierarchy, separate interfaces are there for map. So we will see differently map and we will see differently the collection, list, set and queue. Okay, now I will go through the hierarchy part. So we understood that collection hierarchy at the top is the, as per this diagram, collection hierarchy, and then collection interface, okay, is further extended by the list, set and queue. Okay, and map is also part of Java collection framework, but it does not extend with the collection interface because it stores data in the form of key value pair. Okay, we will understand these things, but for now just keep in mind map will hold values in the form of key and value pair. Okay, whereas collection will hold in the form of values. Okay, so I will take you through this diagram. Okay, don't worry about what it is and how it is, because we will go through by layers. I mean, in the upcoming videos I will cover each and every point. So in this, as part of this video, I will cover some points, I will give you some idea, then later, so that's how we will cover each and every point mentioned in this diagram. Okay, I will be using this diagram multiple times so that we will be clear in these topics. So just now I showed you here collection, you can see, right? Collection. So collection is sub interface of iterable. So iterable is the parent interface. You think like, just focus on the bold letters. Okay, iterable. Forget about the inside pointers for now. So iterable is the parent interface, and then collection is the sub interface of a iterable interface. Okay, so think of it like collection is the child interface of parent interface, that is iterable. Now collection interface is again parent of list subinterface and set subinterface, or you can say child interface. So list and set are child interface of collection interface. Okay, interface means only method declaration will be there. So just see the hierarchy. List and set are the child interface of collection, and collection is the child interface of the iterable, and iterable is the parent interface. Okay, now I explained just now what is the implementation class. Implementation classes means, see, interface, what it will have the method declaration but not definition. That means implementation of that method will be provided by some class. So that some class is implementation class. That means a class which is implementing a interface is called implementation class. Okay, so list is one interface, right? List is a one interface here. Yeah, list is a interface. List is a child interface of collection, but list is an interface. So there will be some classes, right, which will implement this interface. So those classes will be called as implementation class. Okay, so for list interface we have three implementation class: array list, linked list, and vector. So these three are the implementation classes of list interface. Okay, forget about these pointers, focus on the main. So array list, linked list, and vector are the implementation class of the list interface. Likewise, we have set interface, right? This is one of the interface. Set is a child interface of collection interface. Now, since set is an interface, there will be some classes which will implement this interface set. So hasSet is the implementation class of the set interface. This is the implementation class hasSet. Okay, and linked hasSet is the child class of hasSet. So these are the implementation classes. And if you observe, it is sub interface. That means sorted set is again a child interface of set. Okay, sorted set. And tree set is the implementation class of the, there is one more called navigable set. But for now you understand, like tree set is the implementation class of the sorted set, like that you can understand. So I will revisit. Okay, so iterable is what? Parent interface. Okay. And collection is child interface. And list and set are the child interface of collection interface. And array list, linked list, and vector are the three implementation classes of the list interface. And hash set, linked hash set, and tree set. Okay, these are the implementation classes. Sorted set is the child interface of set. So think of it like different hierarchy. Okay, list is one hierarchy and set is another hierarchy. So above list and set, there is common interface, that is parent interface collection, and collection's parent is iterable. So iterable, then collection has two child interface, that is list and set. If we see list, so list interface has three implementation classes: array list, linked list, vector. Okay, now we will go to set hierarchy. For set hierarchy, we have hash set, linked hash set, and tree set as implementation classes. And tree set is different. Tree set is interface implementation class of the sorted set, and sorted set is the child class of the set interface. So first fit this hierarchy in your mind so that moving forward we will understand each one of them and we will know the functionality of each one of them, so you can fit those points in that particular hierarchy. Okay. So hierarchy is clear, right? Now I will explain you this iterator part in later videos. So for now, and I will give you just a brief of list and set. These are like, okay, so here this is list interface. Okay, the basic points, some basic points I will tell you. List. So list is one of the type of collection. Okay. So what is the functionality of list? So list will represent ordered collection. So list is a collection in which we will be adding some values, right? Some objects. So the list will remember the order of insertion. So let's say I am inserting 10, 20, 30 in the list. Okay. So list will remember the order 10, 20, 30. So in the first position of list, 10 will be stored. In the second position of the list, 20 will be stored. And in the third position, 30 will be stored. So it remembers the order of the insertion. So order is significant in list. So this is the one property, one functionality of list. And it supports index-based operations. We will perform in the examples. We will see how index-based operations are performed. Okay. And list duplicates are allowed. Let's say I inserting value, I adding values. I'm adding values such as 10, 20, 30, 30, 40. So list will store 10, 20, 30, 30, and 40. These four values. So even if the values are duplicated, it allows duplicate. So those duplicate values will get stored in the list. And it also allows null values. If you want to store null values in the list, so null values are also allowed. So these are the four major pointers we need to remember for list. Okay. Likewise, we will go for set. So set is what? Set is not an ordered collection. That means it will not remember the order of insertion. That means if you are inserting 10, then inserting 20, then inserting 30. But set will not remember. It can store values 30, 10, 20, whatever. It does not remember the order of insertion. Okay, that's why we are saying not an ordered collection. And also it does not support index-based operation. Index means, I hope you are aware of index, right? We have seen index will start from 0, then 1, then 2. In array, we have seen the same index we are talking about here. And it does not allow duplicates. Set. This is the important functionality of set. If you are writing 10, 20, 30, 30, 40, we are adding one by one. then since 30 is duplicate, it will not allow it. First time it will means, let's say here inserting 10, 20, 30, 30 and 40. We are trying to insert this value. So 10 will get inserted, no problem. 20 will get inserted, no problem. 30 will get inserted, no problem. Since 30 we don't have, right? Now again we try to 30. So already we are having 30. So it will not allow inserting this 30 again. So does not allow duplicates and it allows null. So these are the basic properties of list and set we should know. Okay. And also remember the implementation classes. Array list, linked list, and vector are the implementation class of the list, whereas hasset, linked hasset, and tree set are the implementation classes of the set interface. Okay, so these are basics we should know. And I told you, like, map is altogether new hierarchy. It does not belong to collection interface. Okay, so for this also we will not go into pointers. We will just see the bold letters. Okay, what is the hierarchy for that one? So map, and map stores in the key and value pair. Okay, key and value. So there will be some key and value pair. That's why k comma v. So this is map is the top level. Okay, and then hash map. Hash map is the again implementation class of the map. Okay, map is interface. Okay, interface, and this is implementation class hash map. Linked hash map is also one of the implementation class. Okay, sorted map is child interface of map. Map is parent interface, sorted map is child interface or sub interface, and tree map is the implementation class of the sorted map. Okay, implementation class, see, so many times I'm using. So implementation class is the class which is implementing the particular interface. So tree map is the implementation class which is implementing sorted map interface. There is one in between navigable map. Okay, but for now you understood like this. So for map hierarchy, map is the parent interface. It holds values in the key and value form, key and value pairs. And hash map is the implementation class of the map interface. Linked hash map is also the implementation class. And sorted map is the child interface of parent map interface. And tree map is the implementation class of the navigable map. And navigable map is the child interface of sorted map. So only we need to keep in mind is hierarchy, and the second thing is map works on key and value pair. This is an important point. Key and value pair. Okay, for now this much is good. We will go in the later videos all pointers. Don't worry about these pointers. We will cover each and every pointers with examples in the upcoming videos. Okay, for now just set this hierarchy in your mind so that pointers will get covered very easily if you know the hierarchy. So now we are talking about list interface. Now automatically you should think of that hierarchy. Okay, there was iterable, then collection. These are interfaces, parent interface, and collection was having list interface, set interface, and queue interface. Okay, queue is not was not mentioned in the diagram, but queue will be also there. Okay, and these are what interfaces. And what were the implementation classes of the list? Array list, linked list, vector. What are the implementation classes of the set? Hash set, linked hash set, and the tree set. But tree set, before tree set it was there sorted set. This was child interface of the set interface, and from sorted set, preset was the implementation class. And likewise queue. Queue I have not included in the diagram. For now, you focus on the list and set because these are the most popular. So when I say list interface, this hierarchy should come in your mind. Where is this list in this hierarchy? Trace the list. Okay, here. List is what? Interface. List is the child interface of collection. Collection is the parent interface, and collection's parent interface is iterable. Okay, now we are talking about list interface. So about this we are gonna see. Okay, so list will maintain insertion order. In the diagram itself I explained that list will know the order of insertion. So if we are inserting 10 20 30, it will remember this order and it will insert in the list in the same order 10 20 and 30. The same order it will insert in the list, and it allows duplicates. If we want to store 30, it will store 30 also, and it supports indexing based operation. These are index, right? 0 1 2. So if you want to perform some operations based on index, list supports those operations. Okay, and what are the examples of what are the implementation classes of this list interface? So these are implementation classes. Implementation classes means the class which is implementing this interface. Okay, that means this class will be providing method implementation which is present in the interface. Interface we know, right? Interface means we will be having only method declaration, not definition, not implementation. Only declaration will be there. So those methods implementation needs to be provided, and that will be provided by the implementation class. Okay, so see, implementation classes are, we have seen right over here. So we have, let's say we have one interface xyz. In xyz interface we have method add int a comma int b. Okay, so this is interface. Now implementation class, let's say class abc implements xyz. Xyz what? Interface name, right? See, now in this class we will provide the definition of this method add int a comma int b, and we'll provide definition return a plus b. So we are providing implementation in this class. So this is what implementation class. Implementation class. So likewise, list is the interface, and array list, linked list, vector, those are implementation class because those are implementing list interface. Okay, so these are the implementation classes. So here they have mentioned examples: array list, linked list, vector. This is one and same. Okay, these are the example data. Okay, so a list stores elements in order they are inserted, and it allows duplicate values and supports indexing, meaning you can access elements by their position. Common implementations include array list, linked list, and vector. Okay, now we will go to set interface. I hope now you are able to trace the location of set. So we have iterable, then collection interface, then list, set, and queue. So this is the set interface, and the implementation classes of the set are hash set, linked hash set, and tree set. So these are the three implementation classes of the set interface. Okay, So what are the properties of set? We have seen unique elements only. Duplicate values are not allowed in the set collection. So these are the properties of set. In most of the interviews, they will ask the difference between list and set. So these properties we need to say. In list, it remembers the order of insertion, it allows null, it allows duplicates. In set, unique elements, no duplicates are allowed, it allows null values. Like that we need to understand. Okay. So these are the implementation classes of the set, has set, linked has set, tree set. Okay, tree set, before tree set, it will be sorted. Set is the child interface of the set, and tree set will implement this interface. So tree set is the implementation class. Okay. And these are the example: apple, banana, apple, orange. That means duplicates are not allowed. So whatever is duplicate, let's see, apple is duplicate, right? So apple is stored only one times, and banana and orange is only one time. So it will remove the duplicates. It will not allow duplicates values. That means a set stores only unique elements. If you try to add a duplicate value, it will simply be ignored. And has set, linked has set, and tree set are the most commonly used implementations. Okay. So there is one queue interface, but queue will be looking in DSA. There will be separate playlist for DSA. So I will just brief you what queue is. Okay. So first in, first out. This is the principle of queue. So queue is mainly used when elements needs to be processed in order. Okay. Like ticket counter. In real life also we have seen, right? In ticket counter, whoever is the first in the line, that will be serviced first. That means first out. First in, first out. So whoever is in the queue, in the line first, that will be serviced first. So that will come out first. So first in, first out queue. Okay. And most queues follows this principle. We call it as FIFO. Okay. First in, first out. So this principle, meaning the first element inserted is the first one which will get removed. Queues are commonly used in task scheduling, print jobs, and customer service systems. Okay. And these are the implementations. And this is not the implementation, only queue. Okay. So queue, just know that queue interface is the sub interface of the collection. That's it. Nothing much about queue. Okay. As part of this collection, we will see in DSA separate topic. So map interface. Okay. So for map, we have seen hierarchy. So map does not belong to collection interface, right? It belongs to collection framework, but it does not belong to collection interface. So map has different hierarchy. This is parent interface. And map interface provide implementation classes. Has map, linked has map, and these are what implementation classes. Implementation classes. Has map is implementation classes, linked has map is implementation classes, and sorted map is child interface of map interface. The map is the parent, sorted map is the child interface. And with child interface, implementation class is tree map. So this is the implementation class. So these three are implementation classes. Okay. Linked has map, and tree map. And map store values in the form of key and value. Okay. Remember this point. Map will store values in the form of key and value. So here, here they have provided stores in the key and value examples. So key is, let's say, 101 and value is Rahul, like that. So key must be unique. We cannot keep the same key but values can we can repeat. Okay, here in this case, see, for 101, 103, keys are different, but values are same. Value can be same, but key should be unique. Okay, these are the properties of map. We will see in detail for map, but for now, just I'm briefing what map is. Okay, implementations are hash map, linked hash map, and tree map. So this is the hierarchy for the map interface. So map stores data as key value pair. Every key must be unique, while values can be duplicated. Okay, for example, employee IDs must be unique, but two employees can have the same name. This is the example. And we have seen the hash map, linked hash map, and tree map are the implementation classes of the map interface. Okay, now the question come, okay, we have list interface, set interface, and map interface. Okay, focus on these three major: list, set, and map. So collection means list, set, and map. Okay, now the question comes, when we will use list, when we will go for map, when we will go for set. So before choosing the correct collection, we should know the properties of each one of them so that we can select the appropriate collection based on our business requirement. Okay, so which collection should we use? So different situation require different collection. Okay, so use a list when order matters. So we have seen, right, list will remember the order of insertion. If you are adding 10 comma 20 comma 30, so it will insert in that way only. That means it is an ordered collection. It will remember the order of insertion. If in your application order is important, then you can go for list. And suppose in your application you want unique values. Whatever values I'm inserting, that should be unique. No duplicate is allowed. In that particular situation, you can choose set collection. And first in first out processing you want to do, you can set queue. Okay. And use a map when your data naturally consists of key and value pair, then go for map. So choosing the right collection improves both performance and readability. So based on our requirement, what is our requirement? Based on requirement, we will choose the appropriate collection. Okay. So these are some real world examples. Okay. So a music playlist and shopping cart. Use a list. Why? Because order matters. In shopping cart, order matters. And duplicates are not allowed. So here order matters. Order of insertion matters. And also duplicates are not allowed. Not allowed. Oh, sorry. This is list, right? Duplicates are allowed. So we will go for list. And set, here duplicates are not allowed. Okay, and duplicates are not allowed. Only unique values we will keep. So in that case, like unique email IDs, username. So for these scenarios, we'll go with set. Okay. And queues are commonly used for print jobs, ticket counters, FIFO principle, first in, first out. And maps are ideal for storing relationship like let's say student ID to student name, or product ID to product details, or employee ID to employee details. Okay, employee ID to employee details. So it will be in the form of key and pair. So this is the use case for map. Okay. So let's quickly summarize what we have learned so far. So we understood what collection are, why they are needed, how the Java collection framework is organized. We have seen the collection hierarchy and map hierarchy, and list, set, queue, and map we have covered. So in the upcoming videos, we will go in detail. This was just an overview of the collection framework. So that's all for this video. I hope this tutorial helped you understand the collection overview, and thanks for watching. I will see you in the next video.